fields, add some labels, remove some labels, add headers and stuff like that, and then decide using group tables. You would like to decide, to forward the packet onto one or more ports. This is typically the typical pipeline stage you have in OpenFlow switches. So in case of Telstra, there are like using 2 or 3 tables, not these many. So OpenFlow is also useful for overlay networks, where the the switches are implemented in software. They run typically in the hypervisor. They can also run in the user space of the server. But how overlay networks work is, you know, uh, your virtual network can span across network boundaries, but you can have two VMs belong to the same network, even if they're physically far apart. And otherwise, also you can have two VMs belong to different networks, even if they are on the same physical network. So you achieve those kind of use cases with overlay networks, and you can use OpenFlow protocol to also configure and manage overlay networks. So typically in overlay networks, you use encapsulation like VXLAN header encapsulation, and that allows two endpoints to belong to the same network, uh, even though they are on physically separate networks. So the OpenFlow pipeline can also address that. So you have different set of tables, and then you can also define actions for VXLAN header encapsulation and decapsulation as a set of actions in OpenFlow. Any questions so far? Is this all clear, Frank? Okay. So let's talk about the same services that you're going to implement using Lumina's solution, SDN solution. So there are two types of services: E-line, which is a point-to-point service between two nodes in the network, and then there is a E3 service, which is a point-to-multi-point service. So there's a root, and then there are leaf nodes. So you can have one or more leaf nodes. E-line is a bidirectional service, and E3 is a unidirectional service, specifically in Telstra case. So uh, all these services are actually defined by the MEF body, the Metro Ethernet Forum body, where they are meant to be bidirectional. But the E3 service is a specific use case of Telstra where we make it unidirectional. And in all these services, how they are implemented, there is a layer 1 to layer 4 field lookup in the OpenFlow tables. And this is typically how the next generation MPLS networks, we are implementing MPLS networks in the modern way.
I know we don't do it in Telstra, but is the Lumina controller capable of doing ELANs?
ELANs, I think so. Vish, are you using the Lumina control to implement ELANs?
ELANs, no.
No.
Just ELANs and
Is it in the roadmap?
Roadmap, I'm not so sure. I don't have access to it. So.
Let's check it out.
Yeah.
Okay. So how does the OpenFlow pipeline look like when it comes to Lumina solution? So in the case of E-line, you make use of two tables. So when a packet comes in, the first table you use for doing a service match lookup. So basically you classify the packet based on different fields and decide what service it belongs to. And in the second table, you do the segment routing. So basically you append some labels to this packet and then forward it onto the port to actually to stick to the path for which it has been programmed. So, out here you have this N1 and N2 nodes. So when a packet comes to N1, you would do this first service level lookup, and then in the second table you would append an MPLS label and then forward that packet out onto a port, which would go to the next device in the hop in the path. So, as I said, E-line is a point-to-point service. Its basically use cases are to connect branch offices of organizations, like banks, corporate offices. It could also be between, let's say, data centers, so one data center might be generating data and sending it out to another data center for analytics purpose and stuff like that. There are multiple use cases, but these are typically the business offerings that service provider offer to their customers. So E-line is also known as Ethernet private line or Ethernet virtual private line, and then these are for the popular services by carriers.
So E-lines, so they're between 2 points, but along the path there could be more points that they go through, or is it like two adjoining points?
No, there's a two endpoints. So in between there's a complete
There could be.
path. Yeah. That's the whole thing. So basically, right at the source, you decide what path your packet is going to take. Okay, and as a result, um, you can send your packets faster. So just to draw an analogy, let's say if you want to go from Melbourne to Sydney, you can keep asking for directions at every point, or you can download the directions on Google Map and know upfront how to reach the destination. So
In the picture that you've got on that whiteboard, you've got M1 to M2 with two switches between it, right? It's MPLS in the middle too, right? They don't have flows on them.
so they will have open flows.
I thought the flows only went on M1 and M2.
No, all the devices in between are open flow devices. There's traffic.
But then when you look at the flow table, will you actually see the E-line in there as a flow?
Yeah, so um,
Now that you will see on the controller.
No.
so let's see. So let's say this is your
So on M1, you've got a flow saying if it comes in on port 2 and matches port 80, send it to M2 out port 4, as an example, right? So there's flows which you'll see on M1, M1, and which is the three names there, and M4, right? But in the middle, it's just MPLS labels, right?
yes.
So
It can be a mix of both. That's how we design it.
yeah, but the way Tulsa does it, we don't, right? We don't do flows in the middle, I don't think.
No, I think this whole network path is programmed with OpenFlow.
Well, that was going to be my question. I was getting there. But I don't think I've looked at the flow tables in the middle and seen the flows before. I could be wrong. But
Otherwise, how would it implement?
well, that's what I was going to ask you is how does the MPLS labels get in there?
Yeah, so there is this Lumina Flow Manager application. So when you ask to create a dedicated path between two endpoints, this Lumina Flow Manager has a complete view of the underlying network and the links, and then it could go and program the OpenFlow entries into a different set of
So
devices.
you're saying you think the open flow entry might just simply be so in N1 it has all the details like the import and the matching. But on N2 it just might be as simple as match label 3, send it out, label
Yes.
4.
Yes. So from N1, you might have to go to N2. So N2 will have, so I can explain that. So let's say this is a data packet, let's say, and you append the N4 ID. So that's the ID related to this thing. So when your packet comes in, okay, so right now there is nothing append, this is raw packet. So it will do a lookup onto the fields, like a VLAN ID and port number.
There will be a flow entry in there for it.
Yeah, so there will be a flow entry here, and this would append the ID of that thing, and it would forward it to this guy. This guy would see this is the thing, and there's a flow installed, it would forward it
So
here.
there's a flow just matching the appended header, not looking at the underlying packet anymore, you think?
Sorry.
So the DP, if the flow switch 2 and switch 3 wouldn't be looking at that anymore, they'd just be looking at the
Yes.
N4 ID? Yeah.
Yes, kind of. Yeah.
Yeah.
So there would be multiple labels. It's not very specific to MPLS, so that
But I
would
guess that's at the LFM level where you have to have intelligence that you have to only go 3 hops or you have to go 4 hops because that's where your destination is.
Yeah, where I started before you came in was, are there flows on N2 and N3, or is it just like MPLS?
Like at the segment routing levels, yeah.
Yeah, segment routing labels,
Yes.
but is there flows for the segment routing labels,
Yes.
or is there?
Yeah.
I didn't think so. I didn't think so either, but it's
There it is.
Right. So it's interesting. I've never looked in the form
Yeah,
before.
fair enough.
Okay, you're using the intermittent devices would then, how would they forward the data? There is no separate routing.
36.
So it has to do a lookup on the
Yeah.
device.
That's what I'm.
And these switches would also have the OpenFlow rules, right?
For segment routing.
Yeah.
This is the relevant, right?
That's
Otherwise,
it.
okay.
So the controller will overlay the stack, and
Yeah, because there is no such LC on that thing. There is not a label forwarding information in any of the systems, because they're done. That's why you have to have that rule. For these labels, for
Yeah,
yeah, so he's talking about a rule. He's talking about a rule. If there is this label, then swap it with this label.
Yeah, so essentially like in a traditional network, you've got your L50,
Yeah,
you've got the labels, but then there's no LDP here, so like,
There's no
how
LDP.
do they learn?
Yeah,
So
it has to
is
be a
it
rule.
all flows, all rules, yeah?
Yeah, that looks like.
Yeah, all open flow rules. The entire the service is going to work with open flow rules.
So the only thing is, I think, which probably might help the team over here is, I think we have two tables, right? Inside.
Yes.
So maybe try to and just get an understanding of what those two tables are.
That's what we.
You did just miss that. I think you just spoke about it.
No, but there's
I'll
more,
catch up with you later.
the more details coming, so more body details in inline line. So, okay.
Cannot avoid meetings.
Okay. So we have the E-line, we just understand the E-line data plane. So this is at the ingress node. So we are at, let's say, N1. So let's see how those two tables are used. So when a packet comes in, you do a match on these fields, port number, VLAN ID, the IP protocol, yeah, and then there is a corresponding set of actions which are taken. So those are also defined here. Excuse me. Yeah, so these are the different actions that are taken. So you set the VLAN ID, you push the MPLS layer to VPN header, then you have the MPLS label pushed in, MPLS ether type. So if you understand MPLS networks, you would sort of correlate better. And then finally, on the top of the stack, you would have the segment ID of the last node. So that's the N4, the last node that you would push here. Now that you have done this job, you table 0 would point you to the next table, and there you do a lookup on, this is the top of the stack, the segment ID of the egress node, and on the basis of that, it would point you to the output port in the actions field, and you would forward the packet out onto the output port. So this is on the ingress side, very simple. There are two tables. One do the service level lookup. The another does the forwarding based on the segment ID of the egress node. That is the last node in the network.
No, we are not pushing VPN and privacy.
So this has,
or we don't
I think so. This has actually come from Lumina. These things.
I think that is the what it is. But I
because there is no edge box, right? Who can really.
you're right, but I think we pushed it anyway.
You're right.
Like, yeah. Okay. This part's fuzzy for me, but yeah.
Yeah. Okay. So any questions on this? This is the action. This is how data plane is handled on the ingress node of one E-line service.
It's all right. It's the effort is one in. So if you connect a RDNP today to this network, then you utilize that straight away because the edge will be able to have a look at that in a VPN window.
That was the question before that. This last one is how does it interface with legacy networks?
Yeah. I mean, there are ways.
You would have to peer with a controller.
So
That's
Now we're back to that question again.
Yeah. So
no, so but
how you design
using BGP, there are ways to do it.
It's like contrail or tungsten factory. You're peering to the original router flag, but that's how you get the
No, the controller cannot talk open flow, so the controller has to still have some sort of BGP, understanding from the legacy.
yeah, but that's
And
how
then
you
do
would
that mapping function with the open flow network, and then stitch that together.
Right.
And we can do the example, I held it back before, but it looks like it's coming up again. So you've got a topology, right? You've got a 3-core network, which are just all connected together. You've got 2 legacy PEs today running LDP and OSPF through those 3 things. You want to replace the core with this, right? But you want to keep the legacy nodes. So they want to keep talking OSPF or into the core. Do they now need to peer with the controller, or do they peer with the new OpenFlow box and then they route the LSAs up to the controller? That was the question that I was getting to before.
I think it depends how you design it actually.
So can the OpenFlow box say get the LSA and then say, okay, this is a control packet, send it up to the to the controller and then have the controller form a response to send back to the legacy box?
You can program it that way. That's how you design it, how you design the network and those things.
You see what I'm thinking?
Yeah.
Complicated, way
It's
more.
very complicated, right? I mean, that use case, I mean, we only would replace the port with the open flow switch.
Oh, we never do it.
Yeah, but your question is if we did it and the edge boxes are still talking, it doesn't see anything.
Yes, and keep the Juniper P's, get rid of the C and the CRS.
Correct.
That's what I'm thinking, right?
Correct.
Like, how would that work?
Yeah, so in that case, obviously you'll have to program the rules, for a particular, because you will see your RSVP key, you will see a LTP,
And then you have to replicate
yeah,
all of that.
so you have to actually build a capability within those controllers that whenever a node flow switch is gonna send me a packet of RCP, LDP, and inner VPN label, then depending on what that transport level is, the LDP transport level, so he can perform a path computation, as to what the terminating node is going to be, and then create a segment all the way, or a LDP segment, all the way down to the terminating node, with that rule in each of the cities, like the LDP swap function, you have to do in each of the nodes.
So
But without having that.
So the key is in this scenario, that edge would think that it's running protocols with the no use flow box, but in fact,
Yeah.
it's really been just punching up to the controller.
You need like a gateway box. That's how they do it. In contrast, have a gateway box.
Google, I know, has boxes, just a new feature, so you can everything past that is.
Yeah, and they talk.
I mean, you need the controller to understand OSPF and LDP. I don't know.
Well, the way we do LRDP at the moment is very similar, right? Like, we just craft an LRDP packet and say, let's send this out, the box has no idea about
Yeah.
LRDP.
Yeah.
Makes the packet.
Yeah, that's the topology.
No problem. Okay. So this was on the ingress node. So on the last node, which is the endpoint in this case, you would only have the MPLS service tag, which should tell you what the service is, and then the egress node would then remove that tag from the packet and append a VLAN ID if needed and send it out to the endpoint. So this is
So it
what,
doesn't see the segment of
so it sees this, it sees the port on which the packet is coming and the MPLS service tag. So I think that's what is, I think the SID would be removed.
your service tag is your order too, right?
Yes, yeah. This is the one that would remain actually.
Is it like a POM operation, then, is it?
Yes.
Like the box?
No.
Yeah. Okay. So this is finally when you are delivering the packet to the endpoint. So you kind of pop the headers that were appended and then finally send it to the output port. So let's move to the E3 service. So basically E3 services point to multi-point connectivity. So you have a root node, which is the source of the data packets, and then you might want to send that packet out to multiple leaf nodes. So you can. So it's basically a hub and spoke multi-point connectivity. And the typical use cases in Delta-based is like you want to send out logs and analytics data to different data centers. If I'm correct, right?
It is funny.
Yeah, and then sort of you want to run intelligence in the other data centers on top of that, or maybe you archive the data for legacy, compliance reasons. That's the use case. So yes,
This is the one that you say that saves information because they're sending.
that's correct.
And so bits have like server farms and sends like copies of the data to like multiple responses. So, yeah,
There's some,
because it's just a tap responding makes no sense, right? So,
so there's some TCP handshake.
No, there's no
But
connection.
there seems to be a handshake happening between the main boxes, and this is just listening and sending everything off the
So
server.
send just a transport, but there are two IP transmission points at the end.
So
One is just a listener.
So there's no TCP. So I think it's all stateless transfer. There's no TCP connection, no handshake or sequencing or any of that type. Just plain replication of data. Yeah. So even in the E3 data plane, there's a two table functionality. So let's look at the ingress side of things. So again, we are on node N1. And you again in the first table, you do a service level lookup. So you look at the port number and the VLAN ID of the packet. And on the basis of that, these are the actions that you would perform. So push MPLS layer to VPN, push the MPLS service label, Ethernet type, and the tree path. So tree path label is identifies the path of the tree. So these are how. So this is your different endpoints that this packet has to meet is identified by this three path label. Clear? So in same on the ingress node, there is this replication done. So now in the previous slide we were in this first table. Now the packet is now sort of sent to the second table for lookup. So there it does a lookup on the tree path label, which was pushed in the earlier table. Okay, and on the basis of that, it would point to a group which would tell on which ports this packet has to be forwarded to. Okay, so your sort of tree path is kind of programmed in the OpenFlow tables, and then you would replicate the packets onto the respective ports.
And often the replication points are the ingress node, right?
Yes, yes, that's correct.
So replication point.
It comes in on one box, and then we send it to one or two replication nodes, and then that replication node then sends it out to all the endpoints.
The replication.
So Exhibition and Windsor, I think, are the replication nodes.
But I guess with the new deployment, they wanted to enhance that particular capability where you go and replicate it as close as possible to the user.
Right.
Yeah, because so that you
I
can-
haven't seen that part.
Yeah, but there was a discussion on that. I don't going to check, but that's the ideal way, right? Otherwise, you try and make those 2 points, that these are the ones where I'll just find it.
If it comes in Queensland and your destinations are all in Queensland, it's stupid to send it down to Exhibition just to replicate it 5 times.
That's right, exactly. You send it down and then all the way up again. Yeah, but this is where the beauty of this open source codes is where you don't rely on your traditional multicast as well. You can program the way you want to program your rendezvous points, and in this case, I think they call it
I think it's replication.
replication.
Yeah, the application points is what they call it.
Okay.
Yeah. Okay, so this was about the replication part. Okay, so like we covered the groups in detail when we were talking about OpenFlow. So let's kind of revise that again. So these are the different types of groups that are used for meeting out the E3 service requirements. So group type all, which would replicate the flows onto those many ports. Fast failover, so is another group that is used. So if one of the ports is down, then there is a redundant port that can be used to forward the packet. And then it also does load balancing with the help of select group. So you might have multiple ports combined as one, and then for load balancing purpose, you would forward the packet onto one of the groups. So these are the different groups that are used to create the E3 service with Lumina solution. So again, we are giving an example of how.
So just with the group fast failover, so obviously when the link fails, that's when that fast failover comes into play, right?
Yeah.
If the intercapital link fails, and how it can start sending the package over the other path. So how does are you in the BFD on this on this? I just wanted to understand how the BFD is Google's theory. Like in our traditional network, BFD would trigger something. So we are running BFD today as well.
Okay.
So how all of that relates with each other? With this fast failover and
So I'm not sure about BFT but what I understand is just monitoring the state of the port. I'm not sure if this is tied to BFT. Wish you have any idea?
BFD was the way that it was happening faster.
yeah, that's the thing.
Okay. Do you have any idea how the fast failover works with BFT?
BFT, no, I don't like need to check it. So BFT is something new which we are deploying. Yeah. So we have some limitations also. So OpenFlow in 1.3 NovaFlow doesn't support cleanup of PFT, and we have one more constraint where more than two BFT sessions between two set of nodes is not allowed by NovaFlow.
Yeah.
So we are still working around design to fix these kind of things here.
So with the fast failover, when the table 2 has to match on egress, it will have the on E line, it will have the SRID level of the adjacent node.
No, the SID is always on the ingress node.
Yeah, so which is the egress.
The last node only, the N4 ingress.
So if I, oh, okay. So,
You mentioned four types of flows before, one of them was a failover flow, is that what
Yes.
you did? Yeah.
Yes, that's right.
sorry,
So there's four types of flows before, one of them was like a failover flow. I
yes,
suspect that that's already pre-programmed.
Groups, basically, four types of groups, yeah.
yeah, which tells you which tab going forward. So once this files, you push start.
Yes, yeah, stop using this one, start
You
using
start
this
using
one.
that one, and that node, then that node, which is our just node can figure out how to get to N4.
Yeah, I guess, yeah.
Because that you will have a flow entry or the table entry.
I assume the controller has pushed the redundant flows.
Yeah.
Before that.
It's not,
Yeah.
yeah,
The controller would have done that.
the same, how RSVP has, failover paths, we just wait it out until required.
Okay. So this is, yeah, how EP data plane replication is done. So we just continue with the previous slide again. So, you know, you will have multiple buckets in the group in the all group, and what you would do is you would write the segment ID of the egress node and put it onto the respective port. So you have multiple buckets in the all group, and each one would put the MPLS label segment ID and then forward it to the next device on the next node in the network. And this is on the egress side. So this is similar to, so when you reach the last node in the replication point, you just do a MPLS service level lookup, and also you look up on the port, and then you remove pop the labels and push the VLAN ID and send the packet to the final destination. This is how it would work on the egress side. Okay, so this was about how OpenFlow data plane works, specifically in case of creating MPLS paths using OpenFlow forwarding to you. Any questions on this?
And I asked them the whole way, so.
Yeah.
Move on.
Any more to follow? Welcome. All right. What time is it? 2:45. Okay, so let's go to the now. Yeah. All right. So we have already. So this is on Cloudify. This is going to be the last module for today, unless you want to extend it.
So just with the with our network, how does the controller know which segment IDs for which node? Is there a mapping table within the controller?
Yeah, I think that is programmed through the Cloudify actually. So
Even the segment routing
ID
IDs.
for every endpoint.
You know the DDID?
Yeah.
Okay.
That's them, so we have every NovaFlow box has a DDID configured.
So statically, you configure,
That's actually configured in the mobile process.
Yeah, it's on the switch itself, and the controller obviously knows about it too.
Yeah.
Yeah. So we're going to see an example. So how that blueprint codified blueprint looks like. We're going to see that. Okay. So I think we.
It's node safe. Node safe. Like segment routing node safe.
Sure.
Yeah.
yeah, it's like a loop,
This is a unique identifier. Okay.
like a loop,
Loop.
like a loop.
All right. So we're going to talk about Cloudify again. We did briefly cover it up in the first module. We just gave a high-level introduction. So So Cloudify in Lumina's context has a narrow scope. It leverages some of its capabilities, its capability to add extended functionality. Uh, Typically, Cloudify is actually a very elaborate tool to do complete end-to-end orchestration of network services on an NFV platform. So what that means is that you might have a very big a set of x86 high-end servers connected with switches and routers, and then you want to deploy your different network services. You do it through Cloudify, and so it does all of that in an automated fashion. What that means is it would deploy the virtual machine and containers and install and run the applications onto the platform. It would also do the configuration of the applications of the network. That would be both physical and overlay networks. All of that is taken care by Cloudify. The most important thing about Cloudify is that it is model driven. So you actually feed it a Tosca blueprint file, which is a human readable file that describes your infrastructure as code. And we'll see some examples. So what happens is becomes a declarative tool, just like you gave an example of how you file SQL queries without really worrying about how to fetch the data from the files. Cloudify is analogous to that. You could go and deploy the infrastructure that you want, virtual infrastructure, and create the setup. Not just create it, but it would also monitor it and do lifecycle management tasks. So that and there was a question on YAML, right? So the Tosca blueprint is actually YAML based, which is easier to read and follow.
So you think that slide, you follow that Cloudify creates a dynamic execution of workflow graph.
Yeah.
So how there's a graph of the whole topology.
Yeah. So you define your topology in the blueprint file.
Okay.
Okay, and then it would parse it, and the topology file that you get also has the relationships and dependencies mentioned in those. So it
So the controller uses the LLDP to create this topology and understand the whole network. Whereas the
Tosca is actually
sorry, the Cloudify.
is used for your network service automation, actually. So LLDP is just to detect the topology. So it would know how many network devices are there and how they're connected to each other.
Yeah.
But this is to actually build your cloud setup and also program your network. That is what Cloudify is used for. So that is a very small part. Topology detection is one small part that the controller does.
Yeah.
Okay. Okay. So Cloudify is an open source code from Gigaspaces, and then they of course have their own value offerings. The heart of Cloudify is actually the Cloudify Manager, which is a microservice running within the Cloudify virtual machine. It is the one that handles the blueprints, plugins, and deployments. You can consider Cloudify Manager to a composer of an orchestra. So the composer knows which musician should play which note at what point, because all the notes are in front of the composer. So similarly, the Cloudify has a complete blueprint in front of it, so it knows which application or what should be deployed at what point and what actions to take at what point. So those actions are known as workflow graphs, which are executed by Cloudify. And if you want to access a Cloudify manager, there are different interfaces like the UI, CLI, and REST APIs. So Cloudify is a extensible platform. What that means is you can extend its functionality to connect with different services. So in this case, Cloudify has a plugin to talk to the SDN controller. So there is a plugin defined for that. If you want Cloudify to talk to your AWS machine, AWS cloud, you can do that as well by using an AWS plugin. So with a single tool, you can completely orchestrate your cloud setup. Let's say you have one service running in your private cloud and another service running in AWS. You can do so with Cloudify. So it has got that power actually to manage your cloud centrally, and not just your applications but also the network. So there is a process to define a plugin. So you have I won't get into those details, but there is a YAML file that you have to create, and then you have to write Python scripts for that. Um, so this is an example of a Cloudify plugin blueprint. Yeah. So here, this is a very simple Cloudify blueprint file. So there is this plugin defined server, so cloudify.openstack.nodes.server. This is nothing but pointing to a Cloudify plugin, which would do nothing but install a virtual machine onto one of the compute hosts on the NFV platform. And that virtual machine has certain properties like the security key and then the image ID. So if you want to, let's say, install a Ubuntu image, then the image property would tell you the image ID. And then a virtual machine, of course, has a flavor like how many vCPUs, memory, storage it has. So all that is specified in this blueprint file. So the interesting thing is that this blueprint file will be read by Cloudify, and then it would take the actions which are known as lifecycle management tasks to deploy the virtual machine onto the platform. So Cloudify, its main job is to do lifecycle management of network services. So right from onboarding a service to deploying it, healing, scaling, updating, terminating. So this complete life cycle that you have with an application, right from the point you provision it to you deploy it to termination, and doing other things are taken care by Cloudify. However, in Telstra case, or rather in Lumina's case, you are not going to. It doesn't really deal with all these life cycle tasks. There are only a couple of them, like deploying the E-line and E3 service and maybe terminating it. There is no scaling, healing as such needed. So you're sort of using a very small subset of Cloudify. Maybe your plan is to this is one of the things you want to do with Cloudify of the big picture that you have in mind.
One question. The blueprint that we just saw in the previous page, that one, so it's not a human who generated that, yeah? It's generated by, like, after compiling that
No,
YAML file.
no. So Yang file is different. So okay, this could be confusing. Yang file is completely different here. Yang file is to generate the APIs.
Yeah.
To talk to the northbound application.
Yeah.
That's a modeling. Yang is a modeling.
Yeah. So even this is a modeling. This is also a modeling language. But Yang is a modeling it's a modeling language to talk to your SDN controller applications. Okay, this is a modeling language to orchestrate your entire network services. So these are two different things if you think about it.
But in Telstra case, how do we generate that? Is that you write a script that generates that for you yourself?
So there are two ways. One is you write it by hand. Another is I think you have some scripts to auto-generate these blueprint files. Yeah, that's what I heard in the previous session, that there are certain scripts being written to create these blueprint files.
This is for OpenStack, not using.
No, but we have blueprints as well for SAM. How we
But they would be relying on tree constructs that pushes it up in the controller. This one's about making VMs in an OpenStack environment, which I think is planned, but not done.
Yeah, so there was a use case where the timestamper, VNF use case.
Yeah.
So you could take the traffic, timestamp it out and so on. But I think
Yeah, we're running blockers with this and just get to the next stage.
that's right. Yeah.
So when you actually develop a blueprint, or sorry, a plugin for Cloudify, you also have to write Python scripts to invoke the lifecycle management tasks. So let me take an example. So here, Cloudify was going to invoke APIs on SQL controller. So the invocation of APIs are the Python scripts that you have to write when you develop your own plugin. So Lumina has done that for you. So internally, I'm just kind of explain how things are invoked by the Cloudify plugin. So we talked about lifecycle orchestration of network services and even with Cloudify. And let's get into Tosca a bit. Okay. So Tosca stands for Topology and Orchestration Specification for Cloud Applications, and it's a standards-driven modeling language It has a declarative syntax, so we have used this term again and again. Declarative means you just have to tell what you want to achieve, and the details are taken care by Cloudify. It is written in YAML. It is compatible with the HC Nano standards. So HC is the standards, European standards, telecommunication standards body, which defines the orchestration standards. So Tosca adheres to that. And in Tosca, you not only define your infrastructure as code, but you also can specify policies. And what that means is it may not be in the inline weekly service case, but in general, when you are, let's say, deploying the service and you want to do some load balancing. So Cloudify as a tool always monitors the services and the virtual infrastructure. And based on the policy that you have defined in the blueprint, it would invoke the necessary lifecycle management tasks. Nothing but it would invoke the REST APIs to Python code. That's what it means. So it is used for orchestration of NFV and SDN services. Tosca, right? So Tosca is a file that is fed to Cloudify. So this is a very simple Tosca file, nothing to do with Telstra or Lumina, but a very easy way to define, just to understand what Tosca file looks like. So in this file, we are trying to show how MySQL database is installed inside a virtual machine, and certain properties of the database are passed, like the username and username and user, so username, password, and the port number. So this is a very concise Tosca file. What you see here is you have defined a database server, which uses the compute plugin. Okay, so you can correlate the concepts. Compute is a plugin which is nothing but internally it would spawn a virtual machine onto one of the compute hosts. Okay, and then this is MySQL um, type, which uses a MySQL plugin, and there are some properties, username, password, and the port number for the database. And here you specify where this database is hosted. So this database is hosted on DB server, which is defined here. So your what Cloudify would do, it would first spawn this virtual machine, then it would go and install the MySQL database on that virtual machine. It would start the database server with this username, password, and onto this port. That is what Cloudify does in a very simple way. So you don't have to go and deploy your VM, you don't have to go and install your database onto it. It is all taken care by Cloudify. Make sense?
So where do we get the username password? That dbms.mysql.
So the username.
Tosca.nodes.dbms.mysql.
No, so there is this UBIN as input to the Cloudify. Yeah. So, yes. And maybe when you invoke this through CLI, you can maybe give this.
So when you compile this particular thing.
No, this is not really compiled.
Right.
External, like it doesn't generate user level APIs.
Okay.
Tosca blueprint doesn't generate user level APIs. That is only the YAN piece.
Okay.
Yeah, there are no APIs. This is just passed by Cloudify.
Passed by God.
Internally, it could invoke APIs. So the user is transparent to all this.
Okay. Okay. So those username password has to be there somewhere.
Yes. So when you invoke Cloudify command with CLI, then you can give the input parameter. So when you are
Right.
yeah.
It'll be like something like environment variables. So
Right,
it
right.
keeps it on memory. We're in life anyway.
Oh, there's a graphical interface. In fact, I'll show you when we are coming there. Yeah. So Tosca file is used for orchestration. When you feed Tosca blueprint to an orchestrator like Cloudify, it has the ability to deploy your applications and configure your applications and network onto private and public clouds. That's what it does. It has the capability to even monitor your setup, so it will continuously monitor what's happening in your ecosystem and then take the necessary actions. Cloudify also has a graphical composer, so you can design your services graphically. I mean, to what extent you go, there could be limitations, but you can. This is one of the features, and this is where you can also specify your input parameters actually, on the graphical interface.
we used to use this, and now we exclusively use CLI.
Yeah. So you
Once
hit some,
we moved to E-trees, it was just,
you couldn't do
it
it.
was too much, you had to create 3 different trees to do one E-tree.
Oh, right.
Yeah, so at that point, Vish made a whole bunch of scripts to do it all together.
Yeah, so I thought,
And E-tree was like a single thing, but sorry, E line was a single entry, but E-trees was 3 minimum. So it was too much work.
yeah, these graphical tools are not very powerful yet. Okay, any questions on Cloudify? I hope I was clear on what Cloudify does, how it uses blueprint file, how it is used for automation of network services, and also to program the networks.
So is there a way to load those blueprints in Cloudify? How do you load the blueprints in Cloudify?
The CLI is one on graphically.
Or you graphically load it?
Yeah. So
There's like CF1 commands, so you attach to Cloudify with a whole bunch of commands, and then after that it's from CF1, like install, and then you pass in the blueprint file. And then that connects to Cloudify to talk to the control and push workflows.
yeah. So yeah, the CLI and graphically can do that.
So when you say CLI, that's the CFY command.
Yes, that's correct. So you would actually get to do that hands-on. Yeah. Okay, so let's understand how Lumina escape controller integrates with Cloudify. That's I think the most interesting part for you all. So here you see there is this Cloudify orchestrator, and there is this plugin sitting here, which is the plugin developed by Lumina Networks. And on top of that, you feed a E-line or a E3 blueprint. So this plugin is already there. You've loaded this plugin, and now you give this blueprint to Cloudify through the CLI or graphical interface. And we talked about lifecycle management tasks that Cloudify executes. So when Cloudify will parse the Tosca file, it will invoke the necessary APIs onto the Lumina escape controller. So which would do nothing but go and talk to the Lumina flow manager to create the E9 and E3 services. So whatever we discussed here before the lunch break, that's exactly what is coming here. Okay. And now the SDN controller has multiple applications running, which would satisfy your requirement to create the E-line and E3 services underneath, on the network, which are typically open flow switches. In your case, the low flow switches. So all the switches will be programmed with open flow rules to insert the MPLS labels and to insert the segment ID and populate the tables with the rules for service level lookup and replication points, etc., etc. So all that magic would be done by the Lumina Flow Manager application that runs within the SDN controller. Not clear?
Yeah. Can you repeat again the MD-SAL, what's the main focus of it?
Okay, all right. So MDSAT stands for Model Driven Software Abstraction there. So your controller applications, which means the intelligence that is running within the SDN controller, is built with MDSAL technique. And what that means is that you use Yang models. Now this is where Yang models come into picture. You use Yang models to open up your application for different northbound applications, and also to hook with different kinds of network devices. So your network devices need not be OpenFlow only; they can be NetCon, SNMP, or CLI centric. And your MDSAN application can program your heterogeneous network, which understands different protocols. At the same time, your MDSAN application will talk to the external world using REST APIs. Does it answer your question?
So this is the kind of a module inside your SDN.
That's correct.
But the module is kind of the engine or a correlation engine between
Okay, so that module will integrate your northbound application with the network. So it acts like a translator between the module that runs in the MDSAL as MDSAL application acts like a translator between your northbound application and your network devices. So just to draw an analogy, I mean, let's say if I'm going to China and I don't know Chinese, so if I want to have some food, I can draw something on a piece of paper, and I can show it to the chef. So he understands that drawing, so and he can make the food for me. I think I can take the same.
You better be good at drawing.
The same drawing I can take to Spain and Mexico, then everybody will understand the drawing. Okay, so now I can become a global traveler, right? I don't have to worry about languages. You get the point? You don't have to worry about what language the world speaks. I can just draw, and people will hook with me on with that. That's the whole ideology behind MPSAN application. Make sense?
So, so in our case, same case, when a new customer comes along, he, I guess he'll use the VLAN number, the port ID, and then when the blueprint is created for source to destination, I guess the LFM is the intelligence where it knows exactly, within the MD cell, the whole control as to what rules to create for each. If match on this VLAN, then output for this, and these are the rules which this control push on
Yeah.
the repository, right?
Yeah. So your blueprint will not have open flow rules in there. It will just have
No.
the endpoint specified.
Endpoint specified and the VLANs and
Yes.
and the port numbers.
Yes, that's correct.
Yeah.
Yeah. Yeah. The port numbers. I will see here an example blueprint. Yeah.
And based on those destination endpoints.
The magic will be done by Lumina Flow Manager.
Yeah.
Okay. All right. So coming close to the end of this day one, so we have two blueprints to show. As an example. So this is an example of an E9 blueprint. So you have a traffic generator here, which wants to send traffic from this node to this node, or rather, this is the endpoint. So this is a consumer. This is, let's say, generating the traffic. So you want to create an E9 service between these two communication points. Okay. So you now define a blueprint, and you define this communication point 01, which is this. This is the communication point 2, which is defined here. You specify the properties of these communication points, like the switch ID, the switch port, that answers your question. Then you have the VLAN, okay, and then the segmentation ID. Yeah. And same thing you do for the second communication.
What's the segmentation? That's the SR.
Yes.
Okay.
So every node is identified with a segmentation ID. This is a unique ID for that node.
Okay. So if you're saying like in switch port 2, doesn't make any sense with the context, without the context of which switch you're talking about, right?
Yeah.
So, okay.
Yeah. So
But is that same to the SR ID? Or is it different?
it's the same thing.
Same thing, right?
Yeah, SR ID. Yeah. Okay, so you have defined the communication points using the blueprint, and then you define the path. Okay, now I'll explain how it works. So in the path, you
Sorry. So what's the difference between the switch ID and the SR ID? So
So
you're taking input for the switch ID as well. So
yeah, that's a good question actually. So Vish, you had answered this yesterday, right? Data plane ID and
So yeah, this
segmentation
is switch ID is DPID.
DPID.
Yeah, it's what the user configure in the switch. So it might be 401, 402, 301, 302, things like this. So when a user wants to provision a service,
Yeah.
only thing he needs to know is this ID.
So is the switch ID same as the segmentation ID?
No, that's different. That's internally mapped by the Lumina manager.
So what is the segmentation ID?
Yeah, that's an input. So CP1, upper down segmentation.
Oh, that one. That's actually VLAN number.
No, the VLAN number is here.
Yeah, that's called a segmentation ID.
So you already have a VLAN here. Then.
No, that's not.
That's really
It's
not.
a type.
If it's flat, that
Oh,
will be
okay.
on. Yeah.
Got it.
So what's the segmentation ID?
This is
VLAN.
That's poorly named.
Right. Okay. So the switch ID is really the segment routing node level. The SR ID. The segment ID.
This one? No, this is just a VLAN number.
Sorry. No segment. The switch ID. I mean. So the switch ID is really the segment routing ID.
Yes, that's internally mapped with DPIDs. Yeah.
The DPID that you
Okay. So this is the path that you want to create, and the inputs to this to this I would plug in, or rather the instance of this plugin is, you provide the SDN controller details, and then you provide the two communication points. So this as well as this. Okay, we would provide to this path. So what?
I'm sorry to interrupt you. So what is the SDN config?
So that has all the SDN controller details, port number and IP address of the SDN controller.
So what we just discussed before, CPU1, CPU0 and CPU02 connected.
No. So CP01, CP02 are these two endpoints.
Correct.
And SDN config is, you have to go and talk to the SDN controller, right?
Yeah.
So those details come
Ah,
here. So
Okay.
this may not be completely,
So
not a complete.
Something worth mentioning is the curly brackets are the variables, and the things that aren't in curly brackets are just the scope.
Yeah.
Curly brackets are variables that users input, and the other ones are just fixed, I'm pretty sure.
So that SDN config though, because this is a path configuration.
Yeah. So what will happen
So,
is,
so when you talk about controller,
yeah, so now Cloudify will pass these details, and then it will execute the lifecycle workflow graph to create the path. So it will invoke the APIs to the SDN controller, and that API will be served by the
SDN
flow manager. Yeah. So what Lumina Flow Manager will do is it will return the path back to Cloudify. Okay, and then that path will be attached to the C9 service. That's what it does in terms of workflow management. Or
so it queries the controller returns back the path to Cloudify.
Yes, and then that path is attached to the C9 service. So the path is already created by the controller. It's just sharing the information to Cloudify. Yeah. So I think in that path you can see what are the network nodes that are.
So in terms of the flow of how it goes, so within Cloudify, you load that blueprint which has got the CP01, CP02 details. Then so it knows everything that it has to go into. So it then moves the LFN plugin within Cloudify and goes to talk to the controller with those CPU1, CPU2 details.
Yes.
And the LFM is the one which creates that path.
Yes.
You deploy it in the network, and whatever path is created, it again sends back to Cloudify.
Yeah.
For its own.
Yes, and then basically that path is attached to this E-line service. That's what it means.
Path attached to the E-line service. So what is that for monitoring and so that occasionally knows that for this customer this is the E-line path.
Yes.
So if it goes down,
Maybe they can reference it again with this part of the blueprint.
So the path will be, so the path will come back from controller to the Cloudify.
Yeah, the path is created by
The whole, and then once again, Cloudify sends it down to be translated to actual flows.
No,
Okay,
not
flow
Cloudify.
rules, sorry.
No, it's not Cloudify. Cloudify is only telling the controller lay down the path. Now this is the SDN controller which is doing all the hard work of laying down the path. And then the last thing that controller does is here is the path. So max Cloudify would know is what are the nodes involved in the path.
No, but isn't Cloudify querying the controller to know the path first? That's what we just discussed, right? So at this stage, okay, Cloudify queries the controller, the flow manager basically, to know the path.
No.
Isn't that what we discussed?
No. It's telling make this path from.
Oh, okay. So no information will be back from the controller to the Cloudify.
It will come back. In the response, it will come back.
What response does it send back?
So the REST APIs, it will use REST APIs.
Oh, like acknowledgement.
Yeah, something HTTP API, it would probably tell you the list of nodes involved in the path. Maybe it will tell you the number of, what are the flows installed, what are the segmentation IDs. So that, you will see that in the hands-on lab. So you would actually see, so when you run those REST API commands, you will actually see what is the output.
So once it's deployed to service, it'll bring back the JSON file that we built.
Yeah, correct. It can come in JSON format also, right? So this is what you see in brown is the E-line path created between these two endpoints. A very simple example, just to simplify the understanding. And finally, we have the blueprint for E3. So in E3, you have a root node, and then you have two leaf nodes here, and those two leaf nodes would send the data to the respective endpoints. So similar to the previous blueprint, you define the root node in the Tosca blueprint. Specify some of the parameters. You also provide the leaf node details for both the leaf nodes, these ones. So you have the switch ID, port numbers, and segmentation ID and stuff like that. And then there is this tree path defined in the blueprint. So Cloudify would go and talk to the SDN controller to create that tree path. And in the tree path, we have already specified the root node ID and the two leaf nodes. So you've given all the information to the SDN controller that this is the tree path I want to create. And the controller will do all the work and return back the details to Cloudify, which will be attached to this E3. That's the workflow. So you saw there is a workflow associated with that. Parsing the blueprint file and then understanding what actions need to be taken. And for those actions, Cloudify will invoke the necessary APIs using Python code and get the details back when the path is created by the SDN controller.
Does this E-tree have replication points in there, or does that been left out?
This is a very rudimentary E3 thing. So there's no, even if there is a replication point, you don't specify it in blueprint.
You don't?
I don't think so.
Sure.
Do you specify any replication points in the blueprint?
Good question. So for the automatic replication point, we have some options. Mainly, its replication point is calculated by LFM, but optionally you can specify.
I think we do.
Yeah.
Okay. All right, possible.
It's not an E-tree, it's in tree path though.
Yeah, but with the new design that we're trying to develop, the automatic replication point, we want to understand, we want to give the control to the LFM, because it is a controller, it is the one who makes decisions on the network. So once it has an understanding around where the traffic has to be, where the leaf nodes are, then it can make a decision, locally within the LFM as to, where it can go and select a particular,
Sounds much better.
Yeah.
At the moment,
we hard for it.
if your source is connected directly to a replication point, you don't put that in the config. And so there's like all these special rules you have to remember, or it doesn't work.
If your source is connected to the
Replication point, you don't put the replication point in there, but if it's off anywhere else, you do have to put it in there.
Okay. So it's like a manual, you got to remember this.
So what you're describing sounds much better.
So you have replication points and you specify. Okay, that's all you use. Okay. All right. So that's all for today. Thank you so much. Yeah. Any questions? Want to discuss anything? Toss around ideas. We have enough time for that.
Do you have examples of how, we have missed, but that open flow entity, when you talked about batch actions and then there was counter first parts. Do you have actually examples like how those batch criteria are, how like actually showing the tables? Like if you log in and show some of those tables and open flow entries.
Yeah, so tomorrow there is a demo plan.
Okay.
Recorded demo. So you'll see some of that.
Right.
And hands-on, yes.
Right.
You will be like completely expert in all that. It's all the rules and tables and inline, E3 path, all that will be done. Yeah.
I'll be sitting next to you.
Yeah, definitely. Thanks for being here. I can't stand this for 3 days.
You better talk slowly, all right?
Can't do it. No, it's
This guy.
No, we're not attending that. We're not.
not everybody.
Oh, I think it's going to be very interesting. So if you can sign up with the help of your manager, that's great.
No, I'm not sure.
I'll ask my manager for some help.
Oh, you're
No, I'm a Tom.
you are, yeah,
for sure.
Yeah.
Who made the decision?
Yeah, so it had come to myself and Chris check, as to who should be attending this training. And then we had asked Pravish and Devyani.
ASIC. What is it?
Yes.
It's hardware. So it's a processor.
Is it a SIM?
It's just it's a microprocessor, application specific integrated circuit.
And what does it do?
Basically, it does things like costs, firewall, filters. It does hardware layout.
Quality of service.
Yeah, things like costs.
Toss.
Firewall filtering, policing.
Shaper.
Yeah, it's actually hardly packet forwarding engine.
It's hardware based.
It's hardware based. It's basically like a processor. Yeah.
And then is it Juniper, Cisco?
Every vendor. That has ASICs.
If you have any feedback for tomorrow,
Hardware level, rate limited.
Yeah, exactly right. Yeah, so with Junos, the control plane is your rating engines. So they do things like CLI, SSH, rating protocols, management. Obviously, a place to store the software. Control boarding plane or data plane completely separate. Okay? That handles all your ingress, egress. Packet comes in. On the PC, you've got a whole bunch of ASICs. And Juniper have like Internet Processor 2, for example, and that does like a JSON kind of encapsulation. So, so most of it is things like costs in Juniper terms, policing, enables the control plane just to do its function without any hassles from or the PFP can just basically do your data plane and not worry about it. And also, if the control plane fails, it won't tear down.
I think it's more like Ceph and Cisco Express forwarding.
Yeah, exactly.
There's a hardware-based level.
Yeah, that's it. Yeah. So ASIC, that's
International standard.
Yeah, everything will have ASICs on the data plane.
Thank you.
Even your TV's got a few ASICs in it. Your plasma TV, it's just a microprocessor. It's just programmed. It'll have logic in it to do certain, specific things. Yeah, no worries, mate. It'll be like a COS ASIC. It'll be like a firewall filter ASIC. What else does the PFP do? Yeah, obviously ingress ASIC probably, and egress ASIC. So it's all designed to not rely on the control plane to push a packet through the network. Yeah, that's all it is, mate. Just hardware. Yeah,
Thank you.
All good, mate. No worries.